Assalamualaikum warahmatullahi wabarakatuh, and hello. Today we have Stokes Theorem. Objectives for today are to understand and use Stokes Theorem, to verify Stokes Theorem. Okay, Stokes Theorem is actually a second higher dimension analog of Green's theorem. Okay, it is actually the extended version. Stokes Theorem is named after the English mathematical physicist George Gabriel Stokes. Okay, so this theorem named after Gabriel Stokes, George Gabriel Stokes. Okay, so you can read the info here. So what is actually Stokes Theorem? Stokes Theorem, it is actually related to a surface integral, and it is also related to line integral. Okay, therefore we have a relationship between surface integral and also line integral. Remember, we have line integral before. The integral of curve C of vector field F dot with dr, right? Or it can also be written into the integral of C m dx plus n dy plus p dz. Okay, so you should know line integral. We have that equation. So what is the relationship here? It is actually, if you look at figure number 1, we have the surface integral over an oriented surface S and a line integral along a closed space curve C. Okay, so remember when we have in Green's theorem, we also have closed curve C. Therefore, this one also we have a closed curve C, where it forms the boundary of S as shown in figure 1. If you look at figure 1, we have a solid here, and then we have the C, and your C must be in positive direction, which is counterclockwise. Okay, positive direction here means it is in counterclockwise direction, and it is related to the normal vector n. Okay, unit normal vector n. You know what is unit normal vector n? We had learned this in surface integral in previous lesson. So when we have your curve C in counterclockwise orientation, direction, okay, then you need to imagine that we have your right hand here, and then with your thumb pointing in the direction of 10, your fingers will point in the positive direction C. Okay, if you have if you want to imagine how it works, it is actually you have your right hand, and then the one that curl is actually the direction of your C. Okay, and it must be counterclockwise direction. Okay, the one that curl into your hand is actually the direction of C, and then you have your thumb pointing in the direction upward, right? Which is this is how you know your unit normal is pointing upward. Okay, and then you know that this is actually your surface S. Okay, because first you must have your direction in counterclockwise direction, and then you have the pointing up, which is your unit normal vector n, and then you know this is actually your surface S. Okay, surface S is related to the counterclockwise direction of your curve C. Okay, or you can also imagine if you are the one that who walks along the curve C here, and then the area must be on your left side, right? When you walk here, that means you have the counterclockwise direction, and then if your head is pointing outward, therefore that is the unit normal vector n. It is pointing upward. Okay, it must be pointing outward so that it related to the curve C, which is the direction of your curve C must be counterclockwise, positive direction. Okay, that is the relationship between curve C and also surface S. Okay, you must know where is the curve C and also the surface S, because you want to apply in Stokes theorem. Okay, let's look at the theorem. According to Stokes theorem, so let S be an oriented surface with unit normal vector n bounded by a piecewise smooth simple closed curve C with a positive orientation. Whenever we mention positive orientation, which is it is actually the counterclockwise direction for your curve C. Okay, if your vector field f is a vector field whose component functions have continuous first partial derivative on an open region containing the surface S and the curve C, then according to Stokes theorem, this is the relationship we have. Line integral equals to surface integral, which is the double integral. Okay, so now we have the relationship between line integral and also surface integral. Your left side is line integral for your curve C equals to the double integral for your surface integral. The difference here is, yes, we have for surface integral, curl of your vector field f must be dot with unit normal, and then we have your ds, and ds is actually depends, we have learned this before, which is dA over whether your unit normal and dot with k. Okay, this is when we have your projection on xy plane. Okay, so depends where your projection on xy plane, whether it is on xy plane or yz plane or exact plane. Okay, so this is the relationship according to Stokes theorem. Okay, so you must remember the form of Stokes theorem, which is this one. Okay, note that the line integral also can be written into indifferential form. Okay, usually we have this form, okay, when you want to find line integral. And also note that for curl f dot and ds, the double integral, which is the surface integral, it can also be written into this form. Okay, so you must know the what we have here, the gradient cross product with vector field f is actually the curl of f. That's why we had learned this in earlier in chapter 3, right? Okay, gradient cross product with vector field is also the same as curl f. Okay, so you must know both notation used in Stokes theorem. Okay, one thing about Stokes theorem is when the question asks you to find line integral, you must show surface integral. Okay, when the question asks you to find double integral using Stokes theorem, you must show line integral. It is actually the other side you want to have. Okay, so let's take a look at example number 1 using Stokes theorem. So given to you, here we have the solid of tetrahedron. Let C be the oriented triangle lying in the plane. Okay, where is the plane? 2x plus 2y plus z equals to 6. Because in the equation we have x, y, z. Therefore, you know it must touches all the x's we have here. Therefore, this is the surface of 2x plus 2y plus z equals to 6. And it is also the curve C. Okay. All of this information for C and S must be explained, okay, so that you know what you want to find. Okay, so we have here your tetrahedron. Mentioned here your C is actually the oriented triangle lying in the plane. Okay, so that is your C. This is your C, and then if you look at your C, it moves along the curve C counterclockwise. And after that, why this one is also your S? Because when we have your counterclockwise direction, so using your right hand rule, okay, we have the curl one inside of your hand, and then when you have your thumb pointing outward, so you know it is actually pointing a unit normal positive upward, okay, and then you know this is your S, okay. So for C, we want to evaluate the line integral. For S, you want to evaluate using the surface integral. So you should know both S and C here, okay? So look at the question. Evaluate single integral, which is the line integral, okay? Because the question asks you to evaluate line integral, the integral of a vector field f dot with dr. Hence, using Stokes theorem, you want to actually show the surface integral. Yes, it is as such, okay? You cannot show the one that the question asks, okay? It is actually the other side of the Stokes theorem, okay? Therefore, you want to show using surface integral, okay? So because you want to show the surface integral, which is this one, therefore it involves S, okay? The surface. So you look at the surface S, okay? Okay, so once again, how do you know that is your surface S? Because it is pointing upward, your unit normal pointing outward. Why your normal pointing upward? Because your C move counterclockwise, right? So therefore, you know this is upward. Okay, that is the surface S. Hence, because you want to show using surface integral, you must have your all of your information first. Okay, you know that you want to find the projection on xy plane first, because we had done this in previous lesson. Yes, you want to find the projection on xy plane first. So now, according to your tetrahedron, it is easier if we use here I apply type 1 here, which is you want to use dy dx, okay? Y first and then x. Y is the line equation, x is the coordinate. Okay, so we have our info here for the projection on xy plane. And then you want to also find your curl f, okay? Because you want to show the surface integral. Find the curl f as accordingly as such, and then we have your curl f is actually negative I minus j vector plus 2y k vector, or you can also write your vector as in this form. And then what info we have here, okay, your s, okay, because you want to find the unit normal vector n, okay, find your s, the gradient s, and you know that how when you want to find unit normal, it is actually the gradient s divided by the magnitude of your gradient s. And also you must have the n dot with k vector here, because your unit normal is pointing parallel to your z axis, right? So therefore dot with k, and also because your projection is on xy plane. Alright, so you have all of this information, so you just substitute into your double integral. Okay, because the question asks you to evaluate the line integral using Stokes theorem, therefore you must show this one. Okay, so substitute all of information we have here. Curl f dot with vector n, okay? So vector dot with a vector, then we have plus minus, okay? You just multiply the component accordingly. This is for component I, you multiply, you get negative 2, and then negative 2 multiply with 2, you get minus 2, and then 2y times with 1, you get 2 plus 2y, okay? And then you have also your info, and then you know that when you have n dot k here, and then it can be cancelled out with this one, okay? because both are in denominator. Okay, 3 times 1 over 3. Yes, you get 1. Hence, you just evaluate your projection on xy plane. Okay, because you want to evaluate dy dx, therefore you have all the information here. So you just evaluate using double integral, Cartesian coordinate x and y. Integrate respect to y first and then integrate respect to x. Okay, so you can continue from here and then you should get negative 9. So by using Stokes Theorem, you get negative 9. So for your information, yes, if you find using the line integral, yes, you should still get the same answer, which is negative 9, okay? So let's look at example number 2. Let's continue in next part.